All right, today, 5.4, line of best fit. I'm hoping this should be pretty easy because if you look at this graph right here, what kind of slope does it have? Positive. What kind of slope does this one have?
Negative.
Negative. And this one?
No correlation.
Nothing. You can't decide if it's going positive, negative, so there's relatively no correlation. We can't determine by looking at that. Now on this definition it says a line that best fits the data points on a scatter plot. If it does not, okay, so when you notice these lines, it doesn't have to touch every single one of the points. You know, like when we graphed our linear equations, we'd make 3 or 4 points on the graph and they would all line up and all touch the line. When we do these today, they're not all going to be touching the line. You're going to have to put the line in there somewhere that represents the best possible way. You want to try to get it in the middle of all the dots, all the points. You're not going to, but up here it says that it should have the same amount of points. Well, you're going to try your best to get the same amount of dots on the top and the same amount of points on the bottom. But you can see sometimes, like this one maybe could have been moved up a little bit more, but you want to see too, look at here, 1, 2, 3, 4, you're hitting 5, 6 dots on the line. That's pretty good. All right, so is your line going to be exactly the same as your neighbor's line when you put this on here? Yes or no?
No.
Probably not. But is it going to be pretty darn close?
Yeah.
Yeah, it should be. All right? Now, here's an example. Are yours plotted for you on your notes? They are, right? So you have this exact same graph right here. It says approximating, a best fitting line. The data in the table shows the height of a burning candle over time. After graphing these data points, draw a line that corresponds closely to the data and then write an equation of your line. Beginning of the school year, would have you even known what that meant? Write an equation of the line looking at this?
No.
How about now?
Yeah.
Thank you. Yes, that's what we've been doing over and over. So what they've done is they've taken these points. 0, 0. So what does that mean? 0, 0 at 10. We have a dot right here. What does that mean?
Okay, 0, 10.
So this was what? Right here, it's 0 and 10. This is when the candle was what? Just lit, or 0. Hadn't burned 0 hours, so it is. It's brand new. When we bought the candle, the height of it was 10 what? Centimeters. So when we bought it, it was brand new. It was 10 centimeters. We burned it for a half an hour, and it went down to 9.3 centimeters. After an hour, it was down to 8.1 centimeters. So they put all their points on there, and then you take your straight edge, your ruler, and you're going to have to try to figure out, all right, where's the best line to go through? And a lot of times, it's kind of nice to start at the beginning point if you can, because it gives you a nice ordered pair to work with. You know, here you got 0 and 10. It's a good ordered pair to work with. What would be another good ordered pair? Because you can't pick, like if I had a point like right here, it's not even touching the line. So if we wanted to find the slope of that line, this would be a good point to use. But if I had another one here, I don't want to use that one because it's not touching the line. So you can't use it if it's not on the line. So what would be another good point to use that's touching this line if we wanted to figure out our slope? What and what? We got 0 and 10 and the
3.5.
3.5 and the 4? The 3.5 and the 4? Yeah, I agree. That would be a really good one. So that would be 3.5 and 4. All right? Those would be really good ones. So what would the slope of that line be? These are my x's, these are my y's. 10 minus what on top? 10 minus the 4 on the top. my x's, 3.5 minus, oops, wrong one, 0. So my slope is 6 over 3.5. Simplify. Calculators out. What is 6 divided by 3.5? Or we could clear the decimals and take everything times 10. If I take all these times 10, what do I get? 6 times 10 is over 35. Now simplify that. What would you get? All right, back to this. We divided by 5 and simplified it to what? 12 over 7 is our slope. Or, Mrs. Leonard would also take, if we weren't graphing it, let's write a linear equation. Y equals 12 over 7x, or if it's a mixed number, 1 and 5/7 x. What's my y? She says 10. Yes or no? Is that right?
Yeah.
Is this not a coordinate plane? Why, look at that.
Plus 10.
Plus 10.
Good job.
Nicely done. Okay, so now we practice that one. Find 2 points that lie on the line. We already did that. Look at us. I didn't even tell you which ones to pick, except for the first one, and you guys already picked the one. Were you reading ahead?
Yeah.
Yeah, dang. No, you're supposed to say no. We're just that smart. All right, example number 2. State whether x and y have a positive correlation, negative correlation, or relatively no correlation. What about this one? Positive?
No. Yeah, actually, yeah.
Yeah.
Positive.
Well, let's see. If I were to go through a point, let's see, somewhere, how's that? Pretty good?
Yeah.
Yeah, that's good.
Pretty good point right there. Oops, not that one. That's an extra one. So that would be a positive correlation. And this one, if I go about right in here,
Negative?
what am I going to have to do? Probably move that down a little bit, aren't I?
Yes, ma'am.
It's not moving. I just decorated this more. Anyway, what kind of correlation? Negative. Now, in example 1, suppose we didn't use the points, we used 0 and 10, we used this one before, and we used this one. And we got a slope of, what was it, 12 over 7? That was with those 2 points. Now let's say your neighbor picked these 2 points, 1 and 8.1, and 4 and 2.6. What would the slope of your neighbor have been? 8.1 minus 2.6 on the top, 1 minus 4 on the bottom. Let's simplify that. What's 8.1 minus 2.6? Pardon me? 5.5 over negative 3. I want to clear my decimals, so I'm going to multiply by 10. Move it over once, so I'm going to have 55 over a negative 3. Can I simplify that?
Yes, 30.
Oh, nice job. Because we have to add a 0 there, right? So how about now? 55 over a negative 30. Simplify that. Let's divide by 5. What do you get?
11 over 6. Negative.
11 over 6, and it is negative. Turn that into, is that pretty close?
don't have that.
What did we have here?
We don't have that far.
Was this one?
No.
Was our first slope negative?
Oh, yeah.
So now what? We don't have the same slope. The neighbor has negative 11 over 6. First one, we had a positive 12 over 7, which is pretty close to 11 over 6. Well, what went wrong? What do we have to do? Which one's wrong? Because we should be really close to the same.
Shouldn't the 12 over 7 be a negative?
Should it be? Let's go back and look. So where was the mistake made here?
We forgot the negative sign. No?
No.
No.
There's the mistake. Find it. Raise your hand if you can find the mistake that was made.
I don't know what the mistake is, but if it was a coordinate graph and the line kept on going, it would be a negative slope.
Right, exactly. But we came up here with, look at, the positive. Where is the mistake?
It's supposed to be 0 minus 2.
Nice. Yes, right here. See here? 10 minus 4. We got that right. 10 minus 4. And then we had what?
0 minus
0 minus 3.5, not 3.5 minus 0. So this should be negative, because this should be switched around, 0 minus 3.5. So now, as we compared with the neighbor, what did we find out in our debate? This needs to be negative. Our neighbor was right. We forgot the sign. And like you were just saying, when you look at this is a negative slope. So we have to make sure that our sign matches our graph. Good job. All right, now, do we do these?
No.
All right, number 2. What would we call that?
Relatively no.
Negative correlation, positive, or no correlation?
No correlation.
Okay, so label that. No correlation. How about this one? You going that way? So it is a positive correlation.
That was easy.
And that is it for today. Nice work.